I'm going to go through and explain our new program instruction to file function. You use this function if you're wanting to write your PLC program to a file that maybe you'll later on use your own custom software to do the actual install. So maybe you've got to deploy to a number of PLCs and you want to handle that yourself. You don't want to have to go through vBuilder. This just gives you a file that has all the lines of code that you'll need to write to the PLC, and you can do that from your own script or whatever you'd like to do. So we'll go through it. Now, the first thing we need to note is that oftentimes when you're doing this, you'll want to be deploying to a number of PLCs that have different Modbus addresses. So an important thing when doing this is to make sure that you're either using a fixed number here or leave it blank. Don't make it a tag-based ID. So in this case, we'll make it 7, just so we can see that later on. So the first thing we're going to do is we've got this program that's already made up, and we just click this program instruction to a file that happens to modify my code, and I'm getting a notice there. Okay, so what that does is inside our project folder, it'll create a file with the same name as the project. It'll create it with a .bin extension. And if we were to open up that file in Visual Studio or some other editor like it, you'll see a file similar to this. And I'll go through each of the sections that's important. So the first thing we do pertains to the Modbus address that we were dealing with. You need to know where that address is, because you might need to modify that for each PLC that you're sending it out. Maybe not, but perhaps you do. And if so, this is what's going to tell you where to change that address in the file itself. So you see right here, it's 4 bytes long, and at hexadecimal address 90, you'll find the Modbus address, and you see I programmed it for 7, and sure enough, there's a 7 there. So if you were to modify that to a 3 and then send all this code, you'd be telling that PLC, okay, your Modbus address 3, act accordingly. Okay, so the first piece of data is that Modbus address, and then the next 4 bytes, they tell you the total number of messages that you're going to be sending. So in this case, it's hexadecimal 1F. And then each message is prefixed with 1 byte that tells you how many bytes long it is. So this is 6 bytes long, and then it's message. So 1, 2, 3, 4, 5, 6. So this message is just this section here, and then we've got 4C worth of data, and we go through and we copy 4C of data. So you send them in that order. So we've got first how long the total number of messages is, then the length of the message, and then the message itself, and so forth until the file's over. This happens to be a very small one. Most applications will be a good bit longer than this. When you're doing this, you send one message at a time to the PLC, and then you wait for a response. And you may want to go ahead and have a timeout there in case the PLC, for whatever reason, is being too slow. You might want to recognize that and try resending. But the responses you're getting back, the important part is the byte number 7. You're going to want to see hexadecimal 6 come back in byte 7. That's an acknowledgement, and as long as you get that, then go ahead to the next message. You'll be good. If you get a hexadecimal 15, that's a NAC, and you want to give it a moment, and you want to resend it. You don't actually have to wait any time. It's already given you an acknowledgement. So you want to resend that line if you should ever get a 15 message back. Outside of that, you just go through all the messages that are available, and as long as you get all acknowledgements, you should be in good shape.